used to give extra. I printed, so I made like this called Davis dollars. So I printed like my face
back in
on it.
6th grade?
Yeah, well, people liked it. It was fun, but it just became.
Davis dollars.
What was hard was like you would answer the question, I'd give you guys Davis dollars, and then like some kid that didn't do anything all year would come in and like at the end of the semester with like because people would do something. People were like, there was like a black market for Davis.
Yeah, because like, let's do it.
You would need them, so yeah.
Yeah, I think we should. I'm
gonna lose some. That's kind of fun.
It was kind of fun, but then I can't do it, you know.
What if we promise
And that was just
not
funny
to
because of
sell
my
it?
giant picture of my face.
You have to sign your name on it.
And then you take us to court if we sell it.
Well, then we're just into like, do I want to spend this much effort on something? And the answer is no, you know. So get your notes back out. What does that mean? Oh, that's not me. Yeah. You got a sweatshirt on. You have a t-shirt on?
Yeah.
So you could just take it.
It was. I literally didn't say it.
You looked at me and gave me a dirty look.
Oh my. We're only supposed to have 10. No, we have 10. But she was like, let's use Sharpie. That's too thick. So I have like a bunch of
Alright, fine, please. Everybody here? Well, MCIS and people stumbled down here, honestly. Okay. You like those conveyor belts in the airport.
Those are so fun. You walk like
The what? Yeah, that's what I'm saying. Alright, so we're going to make a couple scenarios here. Draw a little graph, and then x equals 2 is the point that we're going to focus on in each graph. And it doesn't have to be x equals 2, it can be anything. I'm just trying to show you guys a consistent point so we can look at it. And let's pretend that x equals 2 is a river that we are trying to get across. And I'm hiring, who am I going to hire first? I'm hiring Noah. And Noah, I want you to build me roads and a bridge to get over. There's an imaginary river here at x equals 2. I hired Noah's company to build. So Noah comes in and he's building a bunch of road. He's building. He gets to the river and he's like, oh, I can't get over the river. Maybe if I just keep going this way, there'll be some way I can get there. But there's not. And he comes back the next day and he's like, well, maybe if I come from the other side. So I come over here, and I'm going, and I see the river, and I'm like, oh crap, I'm stuck, I'm going to go down here.
how did he get from
How did you
one
get
side to the other?
You can't go over it. I swam.
Let's not get bogged down in the details here. So this is Noah's failed attempt to get over the river. So what, mathematically now, what we have is a vertical asymptote at, be careful how you say this. If you tell me there's a vertical asymptote at 2, that's not correct. That's not enough. Because I don't know if you mean y equals 2 or x equals 2. A vertical asymptote is a line. You have to give me the equation of a line. The equation of a vertical line is x equals a number. In this scenario, what's the limit as I approach 2 from the left-hand side? Positive infinity. No one knows his own mistakes. So as I go toward 2 from this side, what are the y values doing? They're just going up and up forever, right? As I approach 2 from the right-hand side, what's the limit? Negative infinity. And then, is this a removable discontinuity or a non-removable discontinuity? Remember, removable discontinuities are when the limit exists. So does the limit exist here? Be careful. Even if they both went to positive infinity, would the limit technically exist? Remember, the limit technically has to be a real number. So you have to be able able to say the limit is 7, the limit is 2/3, the limit is pi. You can't say the limit is infinity because it's not a number. It's like that thing I was talking about with Maya yesterday. Well, infinity is this. Well, add 1. Oh, it's tricky. Like you can just keep going from it. So this is a non-removable discontinuity. So Noah failed. We fire him.
I need money.
No, well, you should do a better job. I don't know. Noah, pick the next company.
Jocelyn.
Okay, so this is Hobbs Construction Company comes by. What? Oh, okay. So, again, we're trying to get over this imaginary river at x equals 2. Jocelyn comes in, she builds, and she gets to the river, and she's like, alright, I'm going to put a bridge there. That was Noah's mistake, so I'm going to start there. I'm going to put a bridge there. You know, our crew finishes their work, they go home, they come back the next day, but they kind of forget what's going on. They come in from the other side, and they get to here, and, you know, the roads don't even match, so we're still screwed. We still can't go over the freaking height. I should probably look at the plan before I hire people. So, okay. What kind of discontinuity is that? That is a jump discontinuity. Is it removable or not? It is non-removable. It's only removable if the limit exists. What's the limit as I guess I gotta put my values. What's the limit as I approach 2 from the left? Now that I have y values there. 1? Thank you, Tyler. What's the limit as I approach 2 from the right? 2. What's f of 2? 1. If something is going to be continuous, these 3 answers all have to be the same. The limit from the right, the limit from the left, so the road from this way meets the road from this way, and there's a bridge in that spot. We still haven't been able to hire something that can accomplish that. So, Jocelyn, who do you want to hire? Who are we hiring next? Good in construction.
It's gotta be good. It's good. It's in the name.
Right, that's what you're supposed to think, right?
It's supposed to be good.
So, we got this river again at x equals 2. Somehow, this is actually worse. She got worse. So the road comes, and then, you know, her crew's tired or whatever, so they stop, and they're like, we're just going to put a space there, we'll build the bridge tomorrow. Go home, get your rest, come back. You came in from the other side, you got to here, you get to the river. We'll you know, we're tired, we're going to build a bridge tomorrow. Come back the next day, build a bridge, put a twin on there.
Really?
We can't get to this bridge because there's no roads. And we can't cross. No, but there's like forests and stuff in the way. It's too dense. There's nothing we can do. So there's trees everywhere. You just like walk through and put a bridge in the middle of the hole.
Wait, there's trees in your river?
No, inside of the river.
Build a big bridge over the river.
Okay, can we just pretend that this is making sense? Alright, so but the point is like mathematically. What kind of discontinuity is this? Jump? Removable or not? Not removable. What's the limit as I approach x, or as I approach 2 from the left hand side? 1. What's the limit as I approach 2 from the right hand side? 2. What's f of 2? 0. So for something to be continuous, all 3 of those have to be the same. At least in Jocelyn's, we had 2 of the numbers the same. In Gooden's, we got nothing. This isn't even close. This is terrible.
I'd fire her right now.
She's fired right now.
Thought we were correct.
Rachel Madden.
I mean, I would, if I, we'd still be friends, but I just
Did
never
people like,
hire you
was that
again.
like what people would make fun of you? Like,
Yeah.
that's so stupid.
Yeah, no, that's
Anyway, I'm sorry that I didn't mean to bring like flashbacks. She starts like crying. Who's next? Who are you picking next?
Yeah!
Alright.
Oh God, please, yeah, just look at
Abby comes in, she's like, I got this. No one yet has made the roads meet. So my first job, she's like, I'm so focused on. So she comes in, builds a road over here, but they got all the road equipment out already, so they're just gonna keep building roads, and she manages to make the road meet. Which I'm like ecstatic right now. Like this is going places. We got, this might actually work. She goes home, she comes back and builds a bridge way up here.
Bro, what was I on?
I don't know, but you're fired because you're doing drugs on the job. What kind of discontinuity is that?
Removable.
That is removable. What's the limit as I approach 2 from the left? 1. What's the limit as I approach 2 from the right? 1. So far, so good. What's the limit as I approach x equals 2? Oh, that's not Abby's fault. That's your fault. What's the limit as I approach x equals 2? 1. Well, a bunch of people said 2. So the limit exists. So to be continuous, the limit has to exist, the function has to exist, and they have to match. We got the limit existing. That's better than we've done so far. Does the function exist? Is there a value? No, it exists. What's f of 2? 2. Are they the same? No.
Yeah.
So we still can't get over the freaking roof.
Come on, Abby. He spent like millions of dollars for this.
I've wasted billions at this point.
Yeah, like, come on. Let a professional
Oh, wait, what?
show you how.
No, they're. I don't know.
You just have some. You just have like 3 random.
Yeah.
Okay.
So eventually,
Who comes in next?
you got a call. Oh, wait, hold on. Just so we don't think it's Jacob, Jeff Davis.
Davis.
Jeff.
Are you? Jedediah. Jedediah.
I'm like, I'm just gonna do this myself. You guys suck. And I come in and one day I build the road. I'll build the bridge tomorrow. The other day I come in and build the road. And then it occurs to me maybe I should put the bridge in that spot. And this is continuous at x equals 2 because 3 conditions are satisfied. Can you tell me the 3 conditions? Somebody give me one of the conditions. I'm not hiring you again. Jarvis. Limit? Not a complete answer.
The limit has to be like where the point is.
You're trying to give me the whole answer. I just want one piece at a time. I'm not hiring you anymore either. Ashley. So could I just say the limit exists? Because if it's the same for both sides, it exists, right? That's the same thing. So the limit as x approaches 2 exists. It's not an asymptote. It's a real number, and that means the roads meet. Brooke, do you have your hand up? Or is that the one you were going to say?
Well,
The function has to exist, so how would I write that? Like, algebraically, mathematically. F of 2 exists. And then, so Jarvis, you were trying to say this, I think. You kind of combined it all in one. Those two have to be equal, right? So the limit of x as x approaches 2 has to equal f of 2. This is what it takes for something to be continuous. Keep in mind, I don't have to put like a closed dot somewhere to look at it. We're just kind of zooming in on this spot. But for example, is this function continuous at x equals 1? Yeah, the roads meet there, the function exists there, and everything's nice and smooth and comes together. Is the function continuous at 1.3? Yeah, so this function is actually everywhere continuous. That's what that's called. This everywhere.
Go the bridge. It's not that hard.
So there's technically like this road is just consists of bridges over and over again, really. Like, if you think about it that way, all those points out there. What? I don't really understand what you're saying. Yeah, you're fired. Doesn't everything go over something?
So like this, and then
It goes over the, yeah, it goes over the ground. Remember I told you about your brother, the wall thing?
No, it's not a bridge. It's gotta be over. It's gotta be kind of like so there's gotta be like a hole or something. So that it's what I'm trying to say is
Okay.
this is stupid. I'm done. It's not gonna go over your ground. It's not missing.
This is like we're kind of doing like notes and examples. So there's 2 or 3 types of a problem here. I'm going to try to go through like one of each, give you guys the rest of it for homework. And then tomorrow, so this is like the intro to it. Tomorrow, I'll give you the AP questions about this. So we're kind of easing into it a little bit. So there's 2 ways they'll ask it. They could say find and label the discontinuities. Or they could say tell me where the function is continuous. So those are the same questions, just opposite. So let's label the discontinuities first. So everything's nice and smooth here. When I get to x equals -3, I've got a problem, right? What type of discontinuity is that, or what would you call that? So I'm going to say that's the vertical asymptote. Who was the last person to be like that spoke? Abby? Who was the last person that I called on? I think that was the bridge, whatever.
Oh, bridge person.
I'm trying to make sure everyone gets to say something, but it doesn't matter. Where's the next discontinuity? X equals -1. What type of discontinuity is that? That is a jump. Because the limits don't exist, so that the roads don't meet. So you're jumping. Like if I were going down this road, I go here, there's no freaking bridge here, so I have to have some kind of magic jumping power to go down here to get to the bridge. Sidewalk, this magic jumping power. Where's the next one? There's one before that. X equals 1 is what type? Removable. Why is it removable?
Wow.
Does everybody understand? Why is it removable? Mathematically, what's the reason that it's removable? Limit exists. So what is the limit as x approaches 1? It's 1. The bridge is in the wrong spot, but that's what so we could technically remove it, because you're allowed to move bridges, to remove things, but you can't build roads. You can't move roads. Don't ask me about how that makes sense. Where's the next one? X equals 2 is what type? Jump. And then there's one more. X equals 3 is what type? Removable. Why? The limit exists. There's not even a bridge there, but that doesn't affect the limit, right? What's the limit as x approaches 3? 0. Right. Yeah. Question on that. Wait, we're not done. So then, this is you listed the discontinuities. Alternatively, they'll say list where it is continuous. So this is where you're kind of listing around those points. So if you think about just a number line, let's say, so you've got at -3 there's a problem, at -1, at 1, at 2, and at 3. You don't have to write the number line, it's just like kind of easier to explain. You want to list everything except those points. So I want to go from -infinity to -3. -3 to -1. -1 to 1. You see what I'm doing? listing like the gaps in between those spaces? Yeah. Would the negative one be what? A bracket? No, because if I said to you, is this function continuous at -1, what would you say? What are you saying? You would say no, right? So then you can't include it. I think you're thinking because of dots closed, right? But think about it more as is it continuous. And then from 1 to 2, 2 to 3, and 3 to infinity. So they could present it either way. You just gotta your answer in whichever method they use. Fair enough? Yeah.
So the only time that you use a bracket be if there's a line, a close circle, and a line that goes through it, like the bridge that you did.
Yeah, so like you wouldn't, I can't even think of when it will come up, but for example, if I wanted to go, well, okay, -3 to -2 with a bracket, and -2 to -1, isn't this technically saying the exact same thing as this?
Yeah.
It's not necessary, though. Like, I can't even think of a time when you'd have to do a bracket, so it's usually starts with that. Because if it was a bracket, you would just put it into the bigger picture. Okay. That's one time. I can't think of a time you would. Yeah. Okay. So we got these other types here. We got a piecewise I want to look at. We got kind of a factoring one I want to look at. A different type of piecewise, a triple piecewise. And basically I'll do this page, and then you guys do the rest. And it's just like practicing more on the same stuff. So if I look at number 2, same directions. Tell me where there are discontinuities and what type, and then list where the function is continuous. So at a piecewise, what you want to check is the spot where they meet, or perhaps don't meet. We don't really know. So what I'm going to do is there's 3 conditions for a function to be continuous. The limit has to exist, the function has to exist, and they have to be the same. So my first job is to figure out whether the limit exists here. So what do I do to check if the limit exists? Plug in 2 to both sides. If the limit exists, you're going to get the same y value, and that's the limit. And if the limit doesn't exist, what's going to be true about your y values? They're going to be different. So I'm going to plug in, so 3 times, so here, let me write it over. So I'm doing the limit as x approaches 2 from the left. Is going to be 3 times 2 minus 1, which will give me 5. I'm going to check the limit as x approaches 2 from the right. That's going to give me 2 squared plus 2. That gives me 6. Does the limit exist? No. So is this a discontinuity? Yes. What type? The jump. So you'd be jumping y values, right? Like from one side you came to 5, but then you got to jump up to 6 to keep going. So this is a jump discontinuity. At x equals 2. And where is this function continuous? It's everywhere else. So how do I write that? Infinity 2. 2 to infinity. How's that? Okay.
Wait, do you still want? Oh, I didn't see it.
You okay?
Yes.
Okay. Try 4. 4 is different. 4 is a little tougher. But let's do the piecewise one first. That's a different scenario. That's not like a piece and a piece that might or might not come together. The not equal to is a different thing. sure if you got it right, you don't want to write it down. Yeah, that's totally right. Just like think about your answer. So this is what this means. Y equals x squared is your equation for the entire graph except one spot. And what do you have at that one spot?
5.
An open circle. I don't know if it's 5. And then this is a bridge. Well, the question is, if it's going to be continuous, what has to be true about the bridge and the road? They got to be the same. Well, if I plug 2 into this, what should I get? What's the limit of, like, if this wasn't even here, what value would I get if I plug in 2? 4. Well, where's the bridge? 5. So this is the scenario that you have. What is the limit as x approaches 2? Remember, for the limit, I don't care if there's a y value. I don't care where it is. It doesn't matter. So what's the limit as x approaches 2? It's 4. So we got the roads to meet. I forgot, this was Evie's, I think, the roads meet. But then the bridge is in a different spot. What's f of 2? 5. But because the limit exists, what kind of discontinuity is it? Removal. You'll see this sometimes on an AP test. This will be like a K. And they'll say, what would K have to be to make this continuous at x equals 2? What would the answer be? It would be 4. Because then you put the bridge in the same spot as where the road is. So this is continuous from negative infinity to 2 and 2 to infinity. Questions on that one? Try 6. So you got 3 roads here, so how many potential discontinuities do you have? 2. You got to check 2 x values. You got to check negative 1 into both of these. And then check 2 in both of these. I'll go through it. I mean, just try it first. If you're stuck, just wait. I'll do it. So it's like 2 problems in one. We're just gonna kind of pretend this doesn't exist, and we're gonna plug negative 1 into both of these. And what's the purpose of that? What are we trying to find out? If they match, or if there's discontinuity. So if I plug negative 1 in here, what do I get? Negative 3, plug negative 1 in here. I get 1, so those do not match. So what type of discontinuity? Jump discontinuity at x equals negative 1. Because negative 1 is where these two would connect. And they don't. With these two, I'm going to check x equals 2, because that's where those may or may not connect. So if I plug 2 into both of those, what do I get? I get 4. So is that a discontinuity? That's totally fine. So the only discontinuity is at x equals negative 1. Or you can could say it's continuous from negative infinity to negative 1 and negative 1 to infinity.
Do we have to say continuous half x equals negative 2, or do we just leave that out?
They ask you to list the discontinuities, so you don't have to. Because technically, then you could say, like, well, it's continuous x equals 3, it's continuous x equals 4, and, like, list every single point there is, but yeah, there's no.
Well, yeah, like I was just asking because like it's between the two.
Yeah, no, I got you, but you don't have to list.
I don't have to do that.
Yeah, no. Okay, thank you.
Thank you.
Okay, let's do the algebraic one. So, if you look back at your notes from yesterday, I'm going to make you look because it'll kind of put in your brain a little more. Algebraically, what happens if you have a removable discontinuity? 0 over 0. And if it's a vertical asymptote, anything else over 0. Like 1 over 0 is a vertical asymptote. Negative 30 over 0 is a vertical asymptote. 600 over 0 is a vertical asymptote. So, the first thing I'm going to do here is find out, so what's true about both of those? 0 over 0 and something else over 0. What do they have in common? 0 on the bottom. So let's set the bottom equal to 0 and see where that happens. So I'm going to go x squared minus 2x minus 3 equals 0. I get back to that, right? X minus 3, x plus 1 equals 0, so I get x equals 3 and x equals negative 1. Those are discontinuities because the bottom equals 0, but I'm going to ask what kind. So then we have to plug back into the top to see if we also get 0 or not. And if we do also get 0, what kind is it? Removable. And if I don't get 0, vertical asymptote. So plug 3 in here. 3 squared is 9, 9 minus 9. This is removable because you end up, when you plug x equals 3 in, you get 0 on the top and on the bottom. If I plug x equals negative 1 in, I don't even really care what the answer is. Do I get 0? I don't. So this is a vertical asymptote because I got something else over 0.
So the vertical asymptote would be the number on the bottom and not the number on the top?
It'd be the x value that you got from the bottom.
Okay.
We'll plug it into the top to see if we get 0 or not. But if we don't get 0, I don't even really care what it is. I just care that it's not 0.
Yeah.
There's another way to do this that I think it's hard to explain, but some people seem to like it better. Does anybody else do it a different way? Did you factor it and then? So you can look at this and go, okay, x minus 3, x plus 3 on top, right? X minus 3, x plus 1 on the bottom. So which one of those would cancel? The x minus 3, and if you solved that x minus 3, what x value would you get? X equals 3. So the things that cancel, if you took that thing and set it equal to 0, that's removable. The thing that doesn't cancel is a vertical asymptote. And it doesn't matter to me which way you do it. I usually go through this route because it seems to work for more people. But if you're comfortable with this, it's the same process. You're just getting to it a different way. Questions on that one? Try that. So which one's that? Try number 5. Wait, what?
I'm just saying, I think that's how we learned it last year.
This way?
Yeah.
Okay. It's whatever you want. I mean,
So
you're doing the same thing. It's just how you decide to write it.
so anything that's not canceled is a vertical asymptote.
So you look at the two things at the bottom, basically, right? Because that's where the bottom equals 0. If the thing cancels, then that solution is removed. If the thing doesn't cancel, then that solution is a vertical asymptote. Because if it cancels, that means you would have gotten 0 on top also. That makes sense.
Yeah.
So it's the same. It's the same. It's just different.
All right.
Try 5. 5's a little tricky. This seems to throw people off. Yeah. thinking about it, look at number 12. I screwed up the question. This should be x plus 2. Down here, not x minus 2. And then it works, right? Because then you'll have, yeah, that works. Change that in number 12, change the minus to a plus. And then go back to number 5. Sorry about that. Thanks, Josh. So set the bottom equal to 0 is the first step, right? Because any discontinuity, your bottom equals 0. So where's the bottom equal 0? X equals 0. Think about this two ways. Is there a factor on top that will cancel with the x? No, so then it's going to be a vertical asymptote. And if I plug 0 into the top, in place of the x that isn't there, what do I get? I get 5, right? So this is a vertical asymptote. You guys know what 5 over x looks like? 10 over x or anything over x? Hyperbola? Where's the vertical asymptote? X equals 0, right? That's what we just found there.
That one's supposed to be minus, that one's.
Sometimes it's so simple that people make it. So I'm just trying to point it out. Worth, you got a question or are you just stretching it out there? Alright, let's jump to number 11. No, I'm not even going to tell you. You guys figure those out. I'm not going to teach you 11 and 12. I will tomorrow, but I want you to try it first. So finish this. There's your homework. I will put the answers on Schoology or in that folder. Have you guys logged into Schoology and seen the link to the folder? So if you haven't yet, what is this? How did you kind of do it?
Like, I think I went there, but there's nothing in there.
There wasn't anything in there?
Oh, wait, no, look at that.
Let me just show you what I'm talking about. Make sure it works.